Welcome back to the shop and to the channel. Well, last time I got most of the machining done on this little vise for my micrometer stand, but there's a few other things I want to do for it. I want to cut the corners off here just to give it a little more aesthetic, pleasing look, and we still got to make the screw and the knob for it. To cut those angles, I'm going to use this angle block set that was sent to me by a viewer. Now the angle on the ends is going to be 30 degrees. However, because of the way I have to orient it on the milling machine, I need to set up blocks that will give me 60 degrees. To get the 60 degrees, I just need to use a 25, a 15, and a 10, or a 25, a 20, and a 5. All those add up, give me 60 degrees, and that will let me put my part in the mill vise and hold it at that angle while I clamp the vise. Then I can remove the setup blocks. I have both halves of the micrometer vise clamped together temporarily with a socket head cap screw. And now I can use an end mill here to go ahead and take about 220 thousandths from the corner. That's at least the math that I did, or I let Fusion 360 do, to give me the dimension and the length of the angle that I want on each side of the vise. That went pretty smoothly. Now I can remove this from the vise. I'll flip it around, use those setup blocks again, and perform the same operation on the other side. Thing I need to do is put a center hole here in the fixed side of the micrometer vise. Well, to bore the mounting hole, I'm going to use this 1/4 inch solid carbide end mill. Overkill, yes, but it might become obvious here in a minute. I only need this to be about 1/4 of an inch deep. Well, before I can mount this vise to the stand, I need to have something to mount it to. And like I mentioned, I want to use this ball bearing here as a swivel joint. I have some 1/4 inch drill rod that I plan on using for the post. Now the trick is going to be to bore a 1/4 inch hole into this steel ball. When I ordered these things off of the Amazons, I didn't really pay attention that what I was buying was actual ball bearings, because I really just cared to get half-inch steel ball. Didn't realize it was a ball bearing, and that's where the challenge comes from. So these things are hardened, and that's why I was using that 1/4-inch carbide end mill to bore the hole in the bottom of the micrometer vise. I just wanted to use the same tool for both of these boring operations. I'm using my air gun here just to keep a constant flow of cool air across the end mill to keep it from heating up too much, and also to blow the chips away to, give this thing a little better chance at making a clean bore. I'd like to get one of those misting coolant systems like the Cool Mist, but they are pretty expensive. I'm not sure why they're that expensive. The knockoff import ones are really cheap, but are they that much worse? I don't know. I'm thinking about getting one from AliExpress just to see if it's any good. It might be crap, but if it's crap, I won't be out a lot of money. Well, I did make a really nice hole into this ball. I think keeping it cool really had an effect on it. So now I've got a piece of that drill rod. At least I think it might be drill rod. I'm not really sure. It came out of the scrap bin. We'll go ahead and press this in out of the arbor press. Well, that clamps in there really nice. I can put a little bit of force on it and get it to budge a little bit, but I think it'll be fine. I'm not quite ready to mount the vise on here yet. I do want to clean up some of these machining marks on the Scotch-Brite wheel first. Well, the last two parts I need to make are the screw for the vise and the knob. I think I'll use some stainless steel for the screw and a little bit of brass for the knob. I think that'll look nice. I have a piece of 1/2-inch stainless steel rod here. I've got it in the chuck, and we'll go ahead and get this turned down, at least the major features, down to 1/4 of an inch, and then the larger end is 3/8 of an inch. Well, I have a grooving tool that is ground from a piece of high-speed steel. It's only 3/16 square and it's only 60 thousandths wide. I don't have enough room to put the tailstock in, so this thing chattered like a son of a gun. But it's for an E-clip that will retain the screw in the dynamic side of the micrometer vise. Well, I decided I wanted to single point thread this, so I've got the threading tool in the tool holder. I'll run a quick scratch pass here and verify that I'm at 20 TPI before finishing this out all the way. Well, I almost made it. I ran out of room here. I can't move the tool in any further because then it hits the live center, and this doesn't have enough rigidity for me to do this without tail support. So I'll have to finish this off with a regular die. That threads into the vise just fine. So now I can go ahead and cut this off, and we'll turn it around and trim it to length.
Just gotta break it off.
Well, to make the knob, I'm going to use a piece of that same brass rod I used to make the clamp nut for the swivel base. I need to chuck it up in here, and I'm going to trim off that piece that's already been machined. The diameter of it is a little bit smaller than I want the finished diameter of the new knob to be. Well, with that pilot hole drilled, I've got a small boring bar now set up in the tool post, and I need to bore this out to match the diameter of the screw, I just finished machining the large end, which is about 375 thousandths. Well, that's
Oh,
about
that might be a bit
as
too loose.
precise as a hot dog down a hallway. So I blew that dimension, but I think we're going to be okay. I'm going to end up using some retaining compound, some Loctite,
I got none of
to
those.
glue this in. So
Just go run it.
worst case scenario, I might have to remake this part. But for now, I think I'm just going to go ahead and cut it off, and we'll clean it up, and we'll try to glue the two pieces together. Well, I have everything cleaned off with some acetone. And it is quite a loose fit, but I'm hopeful. I am going to prop this up on a couple of razor blades here because I actually want the screw to protrude out the other end of the brass, just so I have something to machine off so that both faces are flat. I've had really good luck with this version of Loctite. I think it can be used up to a 5 thousandths clearance fit, and it'll still work. So I'm hopeful. Well, looks like the glue is holding. So I've got it mounted here in a chuck on my rotary table. I'm going to center this up on the Bridgeport so I can machine the little concave features. I don't know what they're called that go around the outside of the knob here. Well, I have a 4-flute 1/4 inch end mill in the spindle, and I've offset the rotary table now 1.25 inches from the center line, and I'm just machining this feature down. I don't know what this thing is called, what this little concave feature is called. If you know what these are called, I'm sure it's got a name. Leave a comment down below. Now I'm going to rotate the rotary table now 45 degrees and do this again, and we'll keep doing this until we come all the way for a full circle. Well, I've got this single point chamfer bit now in the spindle. I want to put a nice chamfer on that concave feature. I think it'll give it a really nice look. I'm led to believe that chamfers are what separate us from the animals. I actually have the quill stop set so that these are all end up at the same depth, and I am feeding with the fine feed wheel because there's a lot of tool pressure the deeper that this chamfer gets, and I was actually surprised at how much flex there is in that stainless steel screw. You can see it wobbling here as it's cutting that chamfer. You know, it occurred to me that this might come out a little bit better with some oil, so we'll give that a try. See if it reduces some of the tool pressure. I don't think it did, but I think it was worth trying it. Well, I have it mounted back up in the lathe. I want to do two things here. Well, number one is to face off that stainless steel part that's coming through the brass so it matches up with the brass surface. I'm not going to take too much off of the brass, maybe a thou or two. And lastly, I want to put a chamfer on the outside radius here that matches the chamfer that I just machined for those little half moon bits. Well, I took the two halves of the micrometer vise over to the Scotch-Brite wheel and the buffer, put a little polish on it, so got rid of most of the machining marks. There's still a few there, and I think it looks a heck of a lot better. Well, I need to mount the post, the mounting post with the ball on it at the bottom of the vise. Of course, I have to remember to put the clamp nut on first because there's no getting it on after the fact. Well, and my screw here just goes into the clearance hole on the dynamic side of the vise, and I've got this E-clip here that'll fit in that groove that I machined, and this should hold it in here. I don't see why it won't. There's not going to be a whole lot of pressure on this thing or forces on it, so at least in that direction, so it shouldn't have any issues with it retaining the screw. Well, a little demonstration on how this will work. I've got this 1 to 2 inch starret micrometer, and I can clamp it, maybe. Yeah, I can clamp it in that vise at whichever angle will feel comfortable to me. And now when I'm using something like a telescoping bore gauge, I've got both of my hands a little free and comfortable, at least in circumstances in which I can do this on the bench. The clamp nut does a pretty good job of holding it on here, at least with this size micrometer. So it'll be nice to be able to put this in just about any angle, again, that I think would be comfortable in being able to read the micrometer while taking a measurement. This 4 to 5 inch micrometer, which is probably about as big as a micrometer as I think I would use in this. Who knows? Maybe I would use it for one of the larger ones. But having that nice heavy base makes this nice and stable even with this larger micrometer in the vise. Well, I really like how this turned out. Is it perfect? No. Are there some improvements I would make? Yes, definitely. I think I would make the jaws a bit taller. I thought about putting some leather on the face of the jaws to, give it a little bit more grip, but I don't think that I really am going to need that. Well, this was a fun project. It was something I took some inspiration from other projects that I've seen online. Came up with something that's a little bit of my own, and I got to learn some new machining techniques in the process. Well, it's not perfect, not by any stretch of the definition, but it's perfect for me. It's a tool that I wanted. I wanted to make one versus buy one, and it's a tool that I'm going to get some use out of. Now, I do have updated drawings for this that I adjusted as I was going through the process of making it, and I've made those available to my patrons on my Patreon page, and you can find links in the description if you'd like to go check that out. Well, if you like the video, give it a thumbs up. And if you're not a subscriber, consider hitting that subscribe button and the bell icon. It really does mean a lot. And a big thank you to those of you who have subscribed and liked the videos and left a comment. That helps a lot with the YouTube algorithm. Well, thanks for watching, and we'll see you on the next one.